All right. Time management. I think one of the biggest issues in college is time management. It really is. If I can just say one, I know I'm going on and on about this. Really, like my daughter also has a job. She's got a job. But I'm like, honey, keep that thing in about 10, 15 hours. Don't go crazy. Let them know you can't be doing, So my daughter has, and my wife did. My wife played sports and did things, You can have things, but you got to give your math science classes a lot of hours. You have to really control your time. It's not going to bend. Math is not going to, that's what I found. I tried to make it bend. They got an F on that physics test. Math will not bend. It requires that time. All right. Anyway, enough said. So how do we do these? They want us to list all the zeros. So what are the zeros? They are the things that make the function 0, like what x values you can plug in to make it 0. So let's take them one at a time. Let's take this piece first. Take him over here on the side. X squared plus 36. How can we make that equal 0? I mean, what number can I plug in there for x, square it, then add 36, and it'll come out 0? None, right? I mean, do you see that? If you can see that, then we don't even need to play around with moving things around. No way. Nothing's coming out of that part. Let's move on to the next part, right? You all seeing that? I don't want to brush it over, though, and not be helpful. Do you see that any number you plug in there, squared will then be positive, right? Or 0 at the lowest, or positive, because it's squared. Even a negative number squared is positive. Add 36, it's going to be positive. It's not going to be 0. No way you can make that equal 0, huh? So if you know that, you can just look at that and go, nothing there. Let me go on to the next one. Now, I'll show you more formally also. If you jump that 36 to the other side, like that, comes a negative 36, right? So I'll do it formally also. I think it's best just to look at it and laugh at it and go, no way. But it's okay. I'll do it formally. Put the square root over both sides, and you got to put plus or minus. Remember, whenever you tell my algebra students, we put a roof on the house, you got to go up and down the ladder, just trying to remind them of the plus minus when you put the root thing. So now, what is the square root of negative 36? 6i. Remember, it's imaginary when you have a negative in a root. So that's not real, in other words. So there again, same answer. There's no real zeros coming from this part. Let's go to the next part. So either way, formally or informally, just look at the thing or solve the thing and go, no real zeros coming out of that piece of the puzzle. Let's move on to the next piece. So the next piece then is the x minus 8 cubed. How can he equal 0? What can I plug in for x to him to make him 0? Well, 8. Right? Plug in 8 and that's it. I mean, you don't need to do, so if you can just see it, and I think you can just see these ones, huh? It's just 8. 8 is the only number you can plug in there to make that equal 0. The third power isn't going to really do anything important. So x equals 8 is our only 0. Does that make sense on that? It's our only 0. Okay. So yeah, so this is the kind of thing, what's hard is doing math homework, you get stuck. That's why I always encourage, the Roberto and the Tutoring Center, great place to do your homework. They have computers in there. Just go in there between your classes, get your homework done. You have questions, math tutors are right there for you. So the only 0, x equals 8. Next question, B, determine whether the graph crosses or touches the x-axis at each x-intercept. Okay, so first off, we have only one x-intercept. X-intercept is the same word as 0. It's synonymous. So that's the x-intercept, or it's a 0. I want to be clear with you on that. They mean the same thing. An x-intercept is a 0. What is it graphically? It's a place over at 8 where the graph hits 0. It might be that way, might look different, I don't know, but all I'm saying is that over at 8, the graph hits 0. That's why it's called a 0. The graph is at a height of 0. It's also an x-intercept, right? So this is a 0. It's also an x-intercept. So anyway, at that x-intercept, does the graph pass through that point? Or maybe it'll bounce. Have we talked about that? I can't remember. Where they bounce like that sometimes? Did we briefly begin that? Yeah, what did we say? What makes them bounce? Second powers, even powers. Remember that? Even powers make them bounce. So what's the power on this guy? Well, it's 3. The power on the term from which that 0 came. The power is odd. So the power is odd, it's 3, and so that means what? It means it passes through, or they say crosses, same thing, and passes through, or in their words, crosses. And notice it doesn't bounce. So it's not like I'm drawing it. In reality, it passes through there, right? Remember, because even powers are like x squared. And what does x squared do, right? It bounces, right? Just think about the x squared graph, right? It bounces because it's positive. You know, squared is always positive. That's what makes them bounce, huh? Even powers bounce, odd powers pass through, like x cubed. You know the graph of x cubed. It does this. It passes through because it can be positive and negative for odd powers. Okay, so anyway, so odd power passes through. So that's what they want to know. Next one, determine the maximum number of turning points on the graph. Okay, so what are the maximum number? Did I give you that formula? Remember that? I know you guys probably weren't thinking much about it. You were focused on the test, of course. Max number of turning points. What it is, it's the highest degree. Yeah, let's say it that way. Highest degree minus 1. Highest degree minus 1. Okay, well, what's that? How do we find the highest degree? When we say highest degree, we mean if you FOILed that whole thing out. If you took this right here and you FOILed it all the way out, what would be the front term? I'm not going to FOIL it all. That'd be a big pain. But you know what? Without FOILing it all the way out, you could still find what the front term will be, what the most powerful term will be. What will it be? Well, you'd have minus 6, of course, and then you have this x squared plus 36. Let me just take the x squared part. I'm just going for the most powerful. You know, if you would distribute to both, but the most powerful one would be the minus 6 times the x squared, right? And then you would, this x minus 8 cubed, that would be, you know, 3x minus 8s. But what would be the front? You know, if you did x minus 8, I don't know if you can read that up there. X minus 8, it's all written on top of everything. But if you did 3x minus 8s up there, let me write it right here. X minus 8, x minus 8. If you did that and you FOILed that all out, what would be the front term, most powerful term from that? It'd be x to the third, wouldn't it? So let me just put x to the third there. So I'm saying the most powerful thing is going to be whatever minus 6 is times x squared times x cubed, which we all know is what? Minus 6. Let me get this out of the way here. Minus 6x to the fifth. So that's going to be the most powerful term. If we FOILed that whole thing out, if we FOILed all of this out, the front term would be minus 6x to the fifth, the most powerful term. And the rest of the stuff would be smaller powers, fourth power, third power, second power, which means less important terms. This is the most powerful, most important term. And in fact, that's what they want when on part D, when they say end behavior, that's exactly what they want. So let me just write that right here. Get this out of the way. They want you to say that. That is the end behavior. Now you think, why is that the end behavior? Because that tells you what the graph will do in the end. What I mean is, we know the thing hits at 8, right? We've already determined it goes through the graph. If we were to make the graph, it goes through, it has a 0 and x-intercept at 8. What it's going to do in the end means like way over there, way, way off to the end, is it's going to go what? Negative. It's got to go down eventually. Does that make sense? Why? Well, because that means as you plug in really, really, way off to the right, really, really big x values, like 100, 1,000, 10,000, 100,000, way, way, way off to the right, that term is going to dominate the others. It doesn't matter. You might think, well, how do you know, Mr. You might have a plus 500 x to the fourth. Really doesn't matter. You can have plus 5 million x to the fourth. Eventually, he'll win. Plug in a big enough x, go to 10 million over there on the x-axis. Eventually, the higher power wins. Because he'd be 10 million to the fifth. And the other one's only 10 million to the fourth, which means this is another 10 million. He's going to win, eventually. So the biggest power will eventually dictate the outcome. If he's negative, down. If he's positive, up. He will win. He tells you the end behavior. So he's negative, so I know this graph is going down. It's not going up. It's going down. And I know it'll never come up again above the x-axis. How do I know? How do you know it won't come up again and then maybe go down again later? Come above the x-axis and go back down later? What's that? Oh yeah, we'll get to that. But particularly the x-axis. Think about my question with the, how do I know it won't hit the x-axis again? Because this is the only zero. This is the only place where it's ever going to be. If it hit the x-axis again, there'd have to be another zero. And we already found the only way to make this function 0 is x is 8. There's no other x value that you could plug in there. Remember, x squared plus 36 can't do it. No x number you could ever plug in there to make that part 0. The only thing you can plug in to make this part 0 is 8. 8's the only way to make that function 0. 8's the only place it's ever going to hit the x-axis, for sure. Never again. So yeah, it might go up and down, but it won't go above the x-axis. So am I being clear on that? It might go up and down and do stuff like that, but it's eventually going down, 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 and it's never hitting the x-axis again. That much we know. And this other side might go up and down, but it's never hitting the x-axis again either, because there's only one x-intercept. Okay, now, yeah, let's go back to the turning point. So how many TPs are there? Like this is what a TP is, a turning point. Turning point. Maybe a turn. I don't know where or exactly how many, but just giving you, maybe, I have no idea, but maybe it does those turning points where it's going down and comes up and back down, you know. How many could it have at max? Max turning points is going to be 4, isn't it? Let me write that somewhere down here. So max turning point is 5 minus 1 is 4, because 5 is the power. So that's what it's saying. Max number of turning points is the highest degree minus 1. So I took the highest power term minus 1, 4. So at most, now that's max, at most it has 4 turning points. It might only have 3, 2, 1, or none. But at most, it can't have more than 4 though. 4 is the most. Fifth power thing has at most 4 turning points. We good on that? Can I move on from that? So you know that, by the way, just think about x squared. How many turning points does x squared have? It just has the 1 turning point, huh? See how it's 1 less than the power? But then if I was you, I'd be thinking, yeah, Mr. M, but what about x cubed? X cubed, we might think 2 turning points, you know, take the power minus 1. But how many turning points does x cubed have? None. He never changes his mind. He's, as you go from left to right, if you're a little person climbing on this thing, and as you go this way, you're always going up. You never start going down. So he has no turning points. Right. That's why we said this minus 1, 2, is the max. It might have less. It has 2 at most. It could have less. And sure enough, he has none. Huh. Making sense? Now, there's some x cubed graph. I don't know. Let me just make one up. 2x cubed minus 3x squared plus 5x minus 7. I don't really know what that does, but it could go like this. You know, it could have 2 turning points. Some x cubed graphs do have 2 turning points. Some, like the simple x cubed, have none. But none of them have more than 2. That's what we're saying. All right. I think try that one. All right, so try that one. Can you see that one? Yeah. So go ahead. Let's list the zeros and the multiplicity. Here, let me show you what I mean. Over here on this side, they want zeros and they want multiplicity, which means power. Multiplicity means the power. You know, the even, odd, power kind of thing. So go ahead. So find out. And I would just do it by observation. I would just look at that thing and just figure it out by looking at it. So, just looking at this term, what could you plug in for x right there? Can you all see that okay? That would make that term 0. Well, 2, right? And what about this one? What could you plug in right there that will make that term 0? Negative 6, right? That's easy enough, right? We good? And now, for each of those, let's find what's the power on the 2 part? Well, power's 3. What's power on the negative 6? 1, 2. Just like that. Good so far? So it's just the zeros and their powers. Okay, so that means these are the only places where, if you do the graph, you know, only at over 2 and only at back 6, 4, 5, 6. Those are the only places it's going to hit the x-intercept. You know what I mean? Can't touch it anywhere else, because wherever you hit the x-intercept, you're at a height of 0, right? All right, so let's keep going. Now, does it, at these places, does it cross or touch? You know, I say bounce or pass through. So what about it at this one, at x equals 2, at this one? Is this a bounce or a pass-through? It's a pass-through because it's odd. Because this is odd, or they say cross. It crosses, right? It's gonna go like that, or maybe it'll go like that. I don't know which way yet, because I need to know whether in the end it's going up or whether in the end it's going down, and then I'll know which way. But it's one of those two, right? It's gonna cross through there. Okay, now what about at the -6? That's even power, so it's gonna bounce, or what do they say? Touch. They say it bounces, or they say touch. It just touches. I like my verbiage better, bounce. But anyway, they say touch. Okay, so that means it's going to go like this and go boing, or really it could be coming from underneath and go boing. I don't know. I got to figure out that it's all dependent on what the end is. Do you see how once I know the end, then I can kind of trace it back to the beginning? You tracking with me on that? And if the end is positive, then it'll pass through there and bounce there like that. If the end is negative, the end behavior, which we're going to find out in just a minute, most powerful term, then it'll pass through this way and bounce back up that way. It's one or the other, isn't it? There's basically two options for the look of the graph at this point. All right, so let's just go ahead and get to that answer then. What is the end behavior? Let me give you just a second. Rather than me just say it real quick, go ahead and take that. Let's see if you can find the end behavior. So the end, so I'm kind of jumping to part D first because I think it's easier that way. So the end behavior means if you FOILed this out, what would be the front term, the most powerful term? You have x minus 2 cubed and x plus 6 squared. You would have x cubed and x squared. Basically, you'd have x to the 5th, huh? And it's just 1, positive 1, really. X to the 5th. So it's positive. So the point of it is its sign. I don't know if I've said that clearly. Positive up, negative down. So that's going up, up and away. So that means after, what is it, 2? After 2, this thing's going up and away because the end is positive. That's the most powerful term. If you FOIL that whole thing out, the term in the front would be positive 1, x to the 5th. The other stuff is smaller. And he'll win eventually. If you go far enough to the right, he will win. So positive up, and we know it passes through here, and then -6, right? 3, 4, 5, 6. So back at -6, it's going to go like this and bounce. So there's the general look of the graph, just like that. Look how much information you have really quickly about this. Is where it's helpful in calculus. As I say, a picture's worth 1,000 words. It's true. If you were dealing with this function in calculus, you would know immediately, this quick, that this thing is only positive to the right of 2. Everywhere else, it's below the axis, isn't it? You would know quite a bit, and it goes up to the right and then down to the left eventually, and only 2 places. You know quite a bit about that function very quickly. This is kind of powerful analytic information. So max number of turning points, last question. Max turning, I'll write it up here. Max turning, no, not PP, TP. Max turning points. So what is it? Yeah, it's 5 minus 1. My 5s are terrible. 5 minus 1 is 4. Yeah, you just take the power, the most power, highest power, and subtract 1. So it's got at most 4 turning points. Like this is turning point. It might have less, but it's got at most 4. Questions? We good? Think you can whip through those okay? Let's do that. Did I mention you guys did better than the other class. You did well in this test. Your average was high. I was glad to see that. Let's try this one. Same kind of thing. List the zeros. I think your average was 78 or something like that. $78, $79, something like that. So list the zeros and their multiplicity for that one. right, are you getting them? So I want to give you some time to work, but I'm nervous of getting through all the material. So what are the zeros here? Let's take this term first off. Yeah. So this guy first off, you just take the x pieces one at a time, right? So this guy first off, what could you plug in for x right there? Do I need to rewrite it? Can you see it okay? Yeah, it looks pretty big. So what could you plug in for that x to make it 0? Well, yeah, just 0, huh? Just 0 straight. Good, so that 0 is one of the zeros. Okay, now what about that piece? Let's go to this guy now. What could you plug in there to make that parenthesis piece 0? What is it? Yeah, good job. Plus or minus root 3. Two options. Plus root 3. Now, I'll formally solve it also, but if you can just look at it and just say, hey, there it is, by observation, that's even easier, Plus or minus root 3, right? Because root 3 squared, plus or minus, either one, root 3 squared is plane 3, huh? Minus 3 is 0, right? But I'll do it more formally as well. So x squared. So to do it formal, you would just set that piece equal to 0 and then just solve. That's what you can always do if you're not comfortable just kind of looking at it. So then you would get x squared is 3, right? And then you put the root. But remember, like I told my algebra, we put the roof on the house up and down the ladder. You got to put plus and minus, right? When you do the root thing, because there's two options for squared, plus or minus, right? So there it is, plus or minus root 3. Good. So we've got 3 different zeros on this one, 3 different numbers, so that, on the x-axis, when we make our graph, we're going to have plus, root 3 is, if you do it in your calculator, I think it's 1.7 or something like that. So it's a little more than 1. So it knows like about right here, and then, because this is, 1, 2, it's almost to 2, and then it's almost to negative 2, and then, of course, it's 0. So is everybody seeing that? So this is plus root 3, this is 0, and this is minus root. So we're going to have 3 places our graph hits the x-axis, is what that means. No other places than those 3. Now, for each of those, can you write down the multiplicity? And let me let you take it from there. Find out if it crosses or bounces and what the end, you got to get the end behavior so you know what it does at the end, and then you can kind of trace it backwards from there. So the multiplicity is just the power, huh? So what's the power on this guy? Well, 2. Just the power on that x term, just 2. So that's even, and so that means it's a bounce, huh? Or what do they say? Touches. The plus root 3, well, this, oh yeah, no, I need to help with that. That's a little tricky. Yeah, okay. Yeah, to do that, you know what we really, you might look and you go, well, where is that term's 0? Is it here? Is it second power? Well, not exactly that. You gotta factor it. Yeah, let me do that. You really have to factor it. That's right. I knew there was a reason we had to look at this one. So we got to factor. So what you got to do is you got to go like this: x plus root 3, x. So those are both to the first power, and these are both 1. That's what you really have to do to see the multiplicity, the power. Does everybody see that? Now, you might, if I was you, I'd be wanting to know, well, what? I see what you're doing there, Mr. Aaron, and everything, but why can't you just look right there and say it's x squared? Well, the reason you cannot, what a multiplicity 2 would mean, that'd be the same thing twice, right? Like, I think we had one of those back here, didn't we? Well, yeah, here we had, x plus 6 second power. So that was multiplicity 2, because that's the exact same thing twice. That's x plus 6, of course, But this one, these are different, aren't they? They're a little bit different. They're not exactly the same thing twice, so it's not a 2 power. It's 2 different 1 powers, isn't it, when it's factored out. So you have to actually, now you might think, well, you didn't factor back here. Well, right, that one was already in simplified factored form. Do you see what I mean? There's no way to break that down further, right? Whereas this one, x squared minus 3, we can factor that down. We can factor that down. So what do I mean by factor down? I mean you want to get it down to where you have x to the first power with some other power on the parenthesis. X to the first power with some other power on the parenthesis. which is what we already had here. See? X plus 6, that's x to the first power with some other power on the parenthesis. That's factored form, huh? That makes sense. Then the multiplicity is clear. So yeah, when you write it that way, you go, okay, yeah, it's one multiplicity on both those. Is that good? So then these are both odd, so these are pass through, or what do they call it? Cross. It crosses. So that means it crosses. And what's the end? Did you guys get the end behavior? Let's get the end behavior. So if you were to multiply this thing out right here, minus 4x squared, x squared minus, if you were to multiply it out, you'd get minus 4x to the fourth. Wouldn't that be the most powerful term? Pretty easy, you can just, boom, there it is, huh? So minus 4x to the fourth would be the most powerful term. That's negative, so it's going down because of the negative. It's going down. So that means after the 2, or after the square root 3, it's going to go down, isn't it? Now, I don't mean just like straight down, take a dive. It could go down and back up a little and then back down, but it's never coming above the x-axis again because we have no more x-intercepts, right? And but there could be a couple turning points, but it's always eventually going to go down, down, down. At square root of 3, it crosses, so it's going to cross, comes to 0, has to hit there. What does it do at 0? Bounces, boing, and at minus root 3, it crosses there. So the graph generally looks like that. I don't know, it might have other turning points or whatever, but generally that's what it's going to do. I don't know that it has these turning points. So I'll just say that. Is that good? That's generally what the graph looks like. End behavior. Max turning points would be 3, right? At most 3 turning points. Questions? We good? All right. We're going backwards. So there we go. So this time they're giving us the picture. And they want us to go backwards to the zeros and then the least degree of the polynomial. So first off, the zeros. Can you look at that and tell me the zeros? So it's right there. Come on. Right there, and right there. Those are the places it hits 0. So what are those places? Looks like -1 and 3 and 5. Those are the zeros, right? Just where it hits 0. So they just want you to list those -1, 3, and 5. Like that, just list them with commas. Okay, and then what's the least degree? What do they mean by that, the least degree? Well, they mean look at the turning points. Remember the relationship? You know, the max number of turning points, TP, is the degree minus 1, huh? So it's the degree minus 1. So how many turning points do you see on this graph? 2, huh? Right here, it's a TP, and right there is a TP. 2 turning points, right? So if there's 2 turning points, the degree has got to be 3 at most. Wait, is that right? No, at least 3. 3 is the answer. Why is that least? Well, it can't. In other words, it can't be lower than that, right? The degree cannot be 2. Why can the degree not be 2? Because there'd only be 1 turning point then, right? And we're clearly looking at 2 turning points. So the degree can't be 2. Now the degree could be 4, couldn't it? Or 5 or 6 or 7 or 10 million, right? Because 2, there's only 2 turning points, and this is the max number of turning. Whoops, I just erased it. This is the max number of turning points. So the degree could be higher. We don't know that's a 3rd degree function. We don't know, but we know it's not less than a 3rd degree function, all right? Because it couldn't be a 2nd degree. There'd only be 1 turning point. It could be 4th degree, 5th degree, and there'll only be 2 turning points. That's possible. All right. Is that good? So there we go. Look at that. I could do that on the test. Multiple choice A through F. I'm not going to do that. I hope you weren't fooled, by the way, by the E options. I'm not trying to fool you. I'm really not. For example, somebody came up to me during the test, and said, I did all the work, and here it is, and the answer's not here. And that person's work was beautiful. It was perfect. And the person was right. The answer was not there, but I noticed a hesitancy in choosing none of the above. And that's what I said to the person. I said, "Yeah, good job. So choose none of the above. So don't be afraid. Some of them are none of the above, right? I'm not trying to fool you on that. I'm really not. But I got to do that so that you're not just guessing your way through the test. So I got to keep you honest with a couple of none of the aboves in there. So please don't let that fool you. If you do good work and you check it a couple of times and it's not there, with confidence and comfort, choose bubble none of the above, right? I know it's not with confidence. It's disturbing, I know. But I kind of have to put those on there. But don't be alarmed. They're just like the practice exam, right? There are a few none of the aboves on that. So anyway, this is tricky. Not only do they give us A through F, but they say there's more than one answer possible. All right, so they want us to look at that graph, and from that graph figure out which of those are possible. Okay, well, what do y'all think? Yeah, I think the end behavior is a really good idea. Look at the end behavior. Because basically, look at the zeros first off. It's actually not going to help us all. 0, 1, and 2 are the zeros. All these guys have 0, 1, and 2 zeros. It really doesn't help at all. It doesn't eliminate anybody. So yeah, it's the end behavior that really is going to start to make a difference. So look at the end behavior. End behavior is positive, right? It's going up, up, and away. So the end behavior is positive. And so that means that the front term, if you FOILed it out, needs to be positive. Well, let's take a look at this one. If I was to FOIL this one, let's do the end behaviors over here. If I was to FOIL that one out, what would I get? I would get minus 4x cubed. Is that okay? I just take minus 4x times x times x. You just need to grab the most powerful one in each parenthesis, because that's going to be the biggest one when they're all FOILed out, right? So I just grab the minus 4x, the plain x, and the plain x. Minus 4x cubed, which means down. So no way. A's out, huh? That one would have to go down, not up in the end. So that's not right. Okay, good. We eliminated one. Let's go on to B. B, if we FOILed that one out, can you tell me what the end behavior would be there? X squared, this is going to be x squared, and this is going to be x. So x squared, x, x to the 5th, but it's just got a positive 1 in front, so that's up, so that's possible. That could be the answer. B is possible so far, right? We good? See how I'm doing that? I'm just saying if you FOILed out x minus 1 squared, you would get x squared as the most powerful term. And if you had x minus 2, you would just have x. And if you had x squared, you would have x squared. Like that, right? Isn't that good? So if that's confusing, come see me. I always came and saw my teachers. I had lists of questions as I did homework. Every time I didn't understand something, I'd have a piece of paper and I'd write it down. I know it seems obsessive, but that's what it takes to master this stuff. I would write it down. I'd have a list. And I'd find Mr. Pennell or whoever, Mr. Jones in the hall. And I think they were afraid to see me coming. And I there's Brett again with his list of questions. And I'd go, Mr. Jones, why Mr. Pennell? I was Pennell a lot of times. I went to junior college, I think I told you. So I'd find Mr. Pennell, and I said, why on number 17 didn't they do the thing? And he would say, see, because it's that. Oh, yeah, I get it. So then, so ask. What I'm saying now is not clear, get some help, me, tutors, somebody like that. Grab after class. I'm glad to help. That's what I love to help with that stuff. All right, so if you FOILed this one out, what would you get there? You would get 3x to the 4th, that okay? So that one's up is positive. Positive, so that one's up also, so that one's possible. That could be the answer. So far, so good. I can't eliminate that one either. Good so far, keep going. D, what's D? If you FOIL that one out, x squared, right? X squared, x to the 5th again, positive 1. That one's up as well. So that one's, I can't eliminate anybody here. All right, let's go to E. Keep going. E. So if you did E, yeah, what are you going to get there? 3x times negative x times another negative x, actually. So it is positive 3x cubed. That one's up as well. So that one's, I can't eliminate that one. Did everybody see how I got that? Because this is a negative x, and that's a negative x, but 2 negatives is positive in the end. Good, if you foiled that out, right? And then let's try, if I grabbed, say, this one, get negative x times negative, right? Negative x, regular x, which is, again, positive, x cubed, which is up. So I can't eliminate any of those. All the rest of them are going up. Any other reasons I can eliminate? So that's it for the up-down thing. Other reasons, Mondo?
The zero, find the zero. You said you could see that it bounces.
Good job, good job. Yeah, what about the bounce pass-through thing? Yeah, what do we see it? It bounces there.
Zero.
That's a bounce at 0, which means you've got to have an x squared even power. So you got to have an x squared term. So let's look through it. B looks good. C has 3x. No, that would be a pass-through. That's wrong. C's out. Did you track with that, what I just said there? If you have 3x, that's 3x to the first power. That's x equals 0 makes that 0. That is this guy, but it's the wrong power. It's supposed to be 2 power. To be a bouncer point, right? Remember, bouncer points have to be even powers. It's boing, it's bouncing there, and that term is the plane x. I don't care about the 3. I'm just saying it's the plane x. That's what makes it 0, right? As opposed to like x minus 7 or something. That guy would be 7, makes him 0. But a plane x is x equals 0. So the plane x has to be to the 2 power. So no way on C. No way on D, because plane x to the first power right there. No way. Good job, good observation. E, no way. Plane x to the first power again. Can't be. F, no way. Again, plane x to the first power. Yeah, good observation. I told the other class the wrong thing on this one. Yeah, I didn't notice that. Good job. Yeah. Yeah, so it's only B. We're done, right? I didn't realize that, right? Am I missing something? Those are all out, right? It's got to bounce there, yeah. And it's got to bounce at 1. 1's also a bouncer, which is good. B does bounce at 1. See, the x minus 1 is squared. And 2 is a pass-through, which that's exactly what B has, yeah. B's the only candidate here that's working. Just B. Let's go at, let me finish that up all of a sudden too quick. We good? Does that make sense how we wrap that up? We eliminated them all by the bounce thing. I didn't even think about looking at the bounce thing, yeah. Good job. All right, let's look here. Last one. Decide which of the polynomials in the list might. So again, it's the, which ones can fit thing. Yeah, I really got to move on. How about I leave that one? Sorry, I'm going there. I'm like, yeah. I mean, we can talk about it.